I didn't have another battery, but when I took it apart, it seemed like the connection was loose. So hopefully, if I tightened it up, it'll work now. All right. So again, homework 5 is all about the normal distribution. Basically, we got just 2 things we're using in this whole homework. There's norm dist, and you put in the value, the mean, the standard deviation, and 1. This guy is if you happen to know a value that you're interested in and you want to find the percentage that goes with it, it gives you that. So this is if you know the value you care about and you're looking for percent. The other way around is norm inverse. You put in the percent, the mean, and the standard deviation. So this is if you know the percent that you are interested and you want to know the cutoff value. All right. And for both of these, the one thing you always remember is the percent is always area to the left. So like if you know the value and you want, hey, what's the probability you're greater than that value? Well, you do the norm dist, that'll give you the probability of less than, you go 1 minus. Other way around, like if you want to know the top 5%, well, instead of putting top 5% in here, you have to put in, well, top 5 is the same as bottom 95%. So you put in 95% into that guy. All right. Okay, so that was like the first 2/3 of it. And then we said if you're doing groups instead of singles, what changes? I think Catherine knows. What changes? Sigma turns into something else. What is it? Okay. You got it, Ty. Come on. Okay, all that happens whenever you put in your standard deviation, instead of putting it, you just divide it by square root of it, right? Okay, that was the middle part of the homework. And then the very end of the homework is using the normal distribution to approximate the binomial distribution. And we just said, okay, all you do is kind of, you throw in the halves or whatever. So if I want to go from like 11 to 27 with the binomial, well, I would, first of all, I'd go from like 10.5 to 27.5 with the normal. And once you do that, all you have to remember is that the mean for a binomial is NP, and the standard deviation is square root of NPQ. And then you do it just like we did the ones at the very, very beginning. All right. Okay, so since we only got to do like 1 or 2 of those last time, I wanted to do like 1 or 2 more, and then we'll declare victory over homework 5 and get on to 6. So, all right, cool. Let's, okay, close that, close that. Okay, this is what I want. Assume 44% of us have group O blood. A hospital's conducted blood drive. Supply of O blood is low. It needs at least 136 donors. If 264 volunteers donate blood, what's the probability that the group O blood is at least 136? Is 264 volunteers likely to be sufficient? All right, let's grab Excel right quick. Oops. Make it big enough for y'all to see. Okay. So first things first, what we really want is x to be at least 136. When we replace the binomial with the normal, that 136 is going to turn into 135 and a half, right? So I'm going to start out with norm dist. 135 and a half is the number I care about. The mean, well, this is binomial. Either you have O blood or you don't. So the mean is the number, 264, times the p, which is 0.44. So 264 times 0.44, so n times p. The standard deviation is square root of npq, so 264 times 0.44 times, what's q? Yeah, it's 1 minus p, so if 44 have it, that means 56% don't have O blood, and 1. All right. Okay, and is that the answer we want? Why not, Lane? Yeah, again, this always gives us to the left. I want the probability of more than 136 people. So I need to go 1 minus that. Four decimals would be there. So, is it likely we're going to have enough people? Yeah, I mean, we have less than a 1% chance of having enough donors. So we are going to need to find some more people somewhere. Okay, let's do one more. We'll declare victory over homework 5. So 25% of adults smoke. 80 students has found that 16 smoke. Find the probability that should be used for determining whether the 25% rate is correct for students. What can be concluded? That doesn't quite sound like binomial. But 25% smoke. I assumed it would just be the same thing. I'm going to give you an example just to be on the safe side. Okay, yeah, they are just doing binomial, even though that's not the way I would approach this in the real world. But okay. So norm dist, we found 16 students. We're going to bump that down to 15 and a half. We asked 80, and we think 25% smoke. So n times p. Standard deviation, n times p times q, and 1. So 12%. Okay, sorry. That was only half of it. So that was that's the probability of 16 or less, but it wants us to actually find the probability of 16. So we're going to do the same thing with 16.5. 80 times 0.25 square root 80 times 0.25 times 0.75. All right. So this is the probability of 15.5 or less, probability of 16.5 or less if you subtract them. That's the probability that we'd get exactly 16, assuming all of our numbers are right. And no, this doesn't. That's just weird. Well, you just don't like this question. Mm-hmm. First, less than or equal 7. Yeah, they're doing the same thing we're doing. Of course, it's longer because they're using tables. Oh well, I've kind of lost interest. Does anybody just terribly care about this problem? That doesn't terribly care. All right, I'm not gonna sit here and read through the anything. That is okay. Anyway, is it? Yes, not very small. I mean, it's small, but it's not very small. Okay, cool. Let's get on to homework 6. That's what I wanted to do today anyway. Oh, just completely closed out of Google.